Hello and welcome to the Cruise Ships in Venice Group 2 presentation. This presentation outlines a complete, long-term, novel solution to the key problems identified by stakeholders regarding cruise ships in Venice. And the team to achieve this is outlined on this slide, where there is myself, Sean, Cameron, Manaj, David, McKinley and Zidane, and our courses studied and main project responsibilities are also listed. Cruise ships traversing the Giudecca Canal has been problematic for stakeholders of Venice due to the physical, wave, environmental and aesthetic damage they cause. Recently, the Italian government banned ships over 25,000 tons from passing through the Giudecca Canal. This caused more ships to dock at the industrial port at Marghera. However, this solution does not overcome problems associated with damage to the lagoon, hence the need for a new solution. I'm now going to pass you on to Cameron, who's going to talk through the project aims.
So on this slide we have the aims of our project, first of which was to review the current situation in Venice regarding how cruise ships are viewed and the issues that are associated with their presence. Secondly, a new location must be found for the cruise port which can solve some of these issues. Thirdly, a new state-of-the-art cruise port will be designed to fit this location. And lastly, a financial and environmental assessment will be carried out on the project as a whole. The existing cruise terminal is located in Venice, with cruise traffic passing through the Giudecca Canal. This created several environmental and social issues for the residents in these areas. The new port will remain in the Venetian lagoon, but be located on the southern end in Chioggia, accessed through a separate inlet. This port is an existing commercial port which will be repurposed to serve cruise traffic. The next section will expand upon the construction of the cruise port. The design of the port is outlined in the map shown and includes the construction of 5 new terminal structures, 4 of which are new builds and 1 being redevelopment of an existing warehouse in the port. These terminals will serve up to 7 cruise ships at maximum capacity, including the potential of docking Oasis-class cruise ships. Each terminal is paired with a service structure to be used to supply direct utilities to the cruise ships and terminals, as well as to provide storage for any luggage and cargo. Across the port, there are 3 new parking lots for private and shuttle vehicles for transport to Venice or the local area. One of the key features of the design is the construction of a new 600-metre long pier section in the centre of that harbour. This better utilises the open harbour space to provide more berthing points for the port. The terminal itself is outlined in the floor plan shown on the right, with the ground floor being used for passenger management and embark/disembark systems, and the first floor being used for recreational services such as commercial shops, a restaurant and a viewing gallery. This floor plan is for the terminals on the pier section, as there are berthing points on either side of the pier and so require exits/entrances on each side of the terminal. The model below shows an example of how the pier section will look with the terminal structures included. All port decking and foundations will be constructed out of reinforced concrete, with the terminal structures being primarily manufactured out of high-grade steel members, with concrete steel composite decking and aluminium sheet cladding. Substantial sections of the exterior facing will feature glazing so to give wider viewing angles to the passengers of the port, as well as to provide more natural light for the interior of the structure. The project will aim to be built in 3 years from the commencement of construction, with an average labour force of around 600 workers, with appropriate plant and equipment to ensure this can happen. The construction process itself will be split into 3 groups, each taking responsibility of a separate section of the port, as shown in the map to the right. Manaj now will talk about the provision of power to the port.
So in this next section, I'll be speaking about the way in which we're going to power the new proposed port. We're going to speak about the energy demands required, the energy storage required, as well as the energy sources that we plan to use. The first step was to narrow down the areas of interest for power consumption. This was chosen to be terminal buildings and an onshore power supply. The reason in which an onshore power supply was required can be seen in 3 points. The EU have set a deadline of 2025 in which all ports must have a shorter ship connection. Onshore power supply reduces significant emissions, and finally there could be a fuel saving made for the cruise ships themselves. There is a conceptual layout that can be seen in the figure below. The shipping pattern found in the current Venice port allowed for the creation of the graph and the model used for the energy calculation. The total energy demand throughout the whole year came to 175 gigawatt hours. If we were to put solar panels on all the terminal rooftops, it would be able to provide a quarter of the annual energy demand. The optimal angle for the solar panels can be seen as the green colour. And finally, wind turbine energy was deemed the most appropriate after solar panels. Once it was deemed that wind energy was to be used, it was a matter of whether to create a whole new wind farm or to use an existing one. In the end, it was proposed that Romania 1 and 2 are to be used as they provide 800 megawatts of power at any one time. Different power storage options were also looked into, with the reason as to why they were not chosen listed. In the end, lithium-ion batteries came on top with a total volume of 255 meter cubed. I'm now going to hand it over to David, who is going to be talking about water procurement.
Water is required for the cruise ship vessels, the terminal buildings, greening, and for firefighting. Drinking water is sourced using the local water network, which is designed to meet the demands of these requirements. Features can be added to this network to promote sustainability, including both rainwater for greening and seawater for air conditioning. The daily water consumption of all ships is 8,930 meters cubed. The connection between the quayside and the ship is made using an international shore connection, which needs an outlet head of 25.1 meters to meet the level of consumption for the cruise ships. A pumping system is needed and is made up of 37 hygienic centrifugal pumps. A central position is chosen to house the pumps in the port. The requirement for refueling at Georgia is based upon the Poseidon Med2 project and the Gain 4 Moss project, which both promote the increased use of sustainable fuels in the Eastern Mediterranean and the Adriatic Sea. Due to the environmental impact of the current marine fuel used for most of the cruise ship industry and the availability of the fuel, liquefied natural gas, LNG, is chosen as a replacement fuel. An offshore LNG facility in the Adriatic is used to source the fuel, wherein a bunkering ship collects it and, whilst docked in Chioggia, performs ship-to-ship transfers to each cruise ship. A modern LNG bunkering ship has a capacity of 5,800 meters cubed. For all cruise ships, the capacity is 5,700 meters cubed. Any excess fuel is transferred to the on-site storage facility and then to the road network to resell. Advanced safety features are required due to the hazardous nature of LNG, as it is both stored at a cryogenic temperature and at a high pressure, whilst having significant fire hazard properties when exposed to either air or water. Next is the waste management.
So in this next section, I'll be talking about the waste management plan that we have put into place at Chioggia. The new port requires a waste management plan to help keep the port and the environment clean. The Port of Venice did not have its own treatment facility, instead it relied on service providers. However, when designing the new port, it was a requirement to have its own facility to satisfy certain laws and regulations such as the EU Directive 2019/883 and the MARPOL annexes which are set out by the International Maritime Organization. Taking these laws into consideration, the Port of Chioggia will be able to process 5 different types of waste streams on site, whilst using a local service provider to collect one other type of waste. The waste management plan has been developed to meet the laws surrounding the seas and aims towards Sustainable Development Goal 14 to help preserve sea life. So this is the summary of the waste management plan. The 6 different waste streams can be seen and how each one is processed along with the byproducts. The method of disposal or whether it is reused is also stated. Some of the byproducts, such as the liquid produced during aerobic digestion, can be reused as biofuel or fertilizer, and the ash can be used in construction. Other byproducts, such as oil and sludge, are sent to local waste facilities to be disposed. The waste management plan provides some energy through the waste-to-energy facility, which can be used to power the waste management facility or can be used in the terminal buildings. The effluent water produced from the advanced water treatment system can be reused in grey water areas around the terminal. In the next section, Sean will talk about a smart passenger management system.
Smart passenger management aims to improve stakeholder satisfaction by more efficiently using space. Given there is an increasing trend in the number of tourists visiting Venice, this is of increasing importance. The proposed system will enable the implementation of the access contribution in Venice. The following model shows the 109 sub-areas in shaded black and the 401 footbridges in green used for this smart passenger management system. The design solution uses access control to determine the movement of passengers across the 109 sub-areas and the 401 footbridges of Venice. This system consists of speed gates and a visitor management system, where there are 2 speed gates per footbridge to allow for bidirectional travel across each footbridge. Furthermore, a redirection system is in place to disperse traffic across the city, and although the model has been suggested, it hasn't been created, as that is outside of the scope of this project. Redirection routes will be presented by way of redirection devices, where there will be 1 redirection device per footbridge. And to conclude, the proposed system will produce real-time traffic analytics with a maximum error of 4.1%, which corresponds to when people are on gondolas and therefore unaccounted for in the city. Furthermore, the system will compute route diversions in real time to reduce traffic. I'm now going to pass you on to Zidane, who's going to talk through transport.
Given the location of the new cruise terminal, the need for the provision of transport between Chioggia and Venice for tourists became a clear task. By considering the relevant stakeholders, who are mainly the tourists and those who live around Chioggia and along the transport route, 5 criteria were identified and weighted based on their expected significance to these stakeholders. Of the 3 potential transport solutions considered, the first being a direct ferry service between Chioggia and Venice, a direct coach service and a railway service, the railway option was found to be the most effective solution. The use of hydrogen trains as part of the rail service was chosen as they aid in the overall objective of maximizing sustainability and reducing pollution and damage to the environment, as well as minimizing noise pollution along the rail route, as these trains are almost silent. The rail route is 50 kilometers in length and has a total journey time of around 55 minutes, and it travels along the Brenta River between Chioggia and Padova, thus minimizing the use of urban areas and farmland. The rail route also utilizes existing rail infrastructure upon entry into Padova Station. Padova Station is used as a changeover station where tourists can take an express train into Venice. The railway service uses 10 hydrogen-powered trains made by French company Alstom, while the coach service uses 5 electric coaches. Both are chosen due to them releasing 0 harmful emissions at the point of use. Additional infrastructure needed along the route include 11 level crossings and 4 railway bridges. The train station is located less than 400 meters to the south side of the new cruise terminal. It also has a coach station integrated alongside it, which feature a coachyard and coach stops, which aid to alleviate the pressures on the train station during times of increased tourism. The train station itself has a total area of 20,000 meters squared and features 2 train platforms, one for inbound trains and the other for outbound trains. The station also includes other facilities typically found in train stations, such as waiting areas, a cafe, and lavatories. The next slide is covered by McKinley, who will go over the financials of the project.
In this section, we will briefly go through these financial analysis of the project. The cash flow curve has been generated using the income and costs related to the project. From this information, we can deduce certain parameters. The payback period for the project will be 11 years. The profit at the end of the 30-year period stands at 1,790 million euros, which gives a return on investment of around 14%. From this curve and data, it's fair to say that the project is financially viable.
Sustainability took a key role within the project, and it was continuously evaluated throughout. 2 life cycle assessments were qualitatively carried out on both the terminal system as well as the train system. The inventory analysis of the terminal can be seen on the left with the different inputs and outputs shown. Social sustainability was also evaluated within the final report. As a project, we believe we are working towards 7 of the United Nations sustainability goals. And to give a few examples, an onshore power supply, we believe, develops the UN goal number 3, as this reduces emissions of a previously commercial port. A hydrogen train would also develop UN goal number 11, as it provides transport for people nearby, not only the tourists. I'm now going to hand it over to Zidane, who will now conclude the project.
In conclusion, this project has successfully relocated the cruise ship terminal from Venice to Chioggia, avoiding the use of the Venetian lagoon. Detailed designs of the new terminal and docking areas, as well as the facilities within the terminal, have also been produced. An effective and environmentally friendly transport link via railway was chosen and designed between the new terminal and the city of Venice, and the sustainability of the entire project was critically analysed using 2 life cycle assessments. The total cost of the project was estimated, and a financial analysis was carried out to determine the expected payback period of the project being 11 years. Thank you for watching our presentation.